Hello everybody, welcome to Mr. Soto's class. Today we're going to be going and solving inequalities, okay? So solving inequalities is the same as solving equations, except they're no longer equal. In this case it is, but you're going to have one side that's greater than the other. So when we have an example like this, p minus 8 greater than or equal to negative 13, you're trying to isolate the variable, so we're going to try to get rid of the 8. And so all we're going to do here is we're going to go ahead and cancel the 8 here by adding 8 to both sides. Since they're subtracting 8 from the p, we're going to do the opposite. Add 8 to from the left side, and then add 8 on the right side. So on the left side, the 8s are going to zero out. Negative 8 plus 8 is 0. And then bring down the p. Inequality stays the same. Now you have a negative 13 plus 8, and that's going to give you negative 5. The variable's by itself, so that's how you know you're done solving for the variable. And now you have to do is graph it on the number line. So you look for the negative 5 on the number line, and you're going to circle it. Now when you're dealing with inequalities, there's two types of circles. You're either going to have an open circle or a closed circle. How do you know whether it's going to stay open or closed? Well, you got to look at the inequality. If the inequality is less than or just greater than, the circle will be open. But if it is less than or equal to, or greater than or equal to, then the circle will be closed. In this example, we have a p is greater than or equal to negative 5. So because it is equal to, right here, greater than or equal to, we're going to go ahead and shade in the circle. We're going to have a closed circle. Okay, now we have to determine whether it's going to go this direction or that direction. How can we tell? Well, you have p greater than or equal to negative 5. If you're not sure about which side is greater than or less than, just choose a number. Say for example, I was to pick, I don't know, the negative 7 right here. And if I plug it in for the p, I would have negative 7 greater than or equal to negative 5. Is negative 7 a greater value than negative 5? In math, guys, the bigger the negative, the smaller the value. So no, this is not going to be a greater value than negative 5. So this does not make sense. Okay, so that means that we have to go in this direction, and you can always test it. So let's just choose, I don't know, negative 2, for example. Or even another number like a positive 2. Does not matter which one, guys, but just know that positive 2 will be greater than a negative 5. 2 greater than or equal to negative 5, yes. Negative 2 is also greater than or equal to negative 5. So yes, this makes sense, which means that our arrow will be going in this direction. Okay? And that's how you do these inequalities. So now we have example number 2 here. And if you look, it looks like we have 2 inequality symbols in this problem. So whenever you see something like this, guys, it's considered a compound inequality. We're still solving them, and we still have to graph it on the number line. So let me show you how we do this. 10 is less than x plus 4, which is less than 12. And so what we're trying to do is we're going to end up breaking this compound inequality into 2 parts. So we're going to get this first piece, pretend like this piece is not here. We're going to separate it over here. We have 10 less than x plus 4. And then we're going to work this out on its own. And then on the other side, we're going to go ahead and block this piece out, and we're going to work this problem out on its own as well. So I might have space right here. X plus 4 less than 12. Okay. So put them together, it becomes this. We split them up so we can go ahead and work it out like we did on the previous example. And if you look here, we have 10 is less than x plus 4. We're trying to isolate the variable here, so we want x to be by itself. And so we got to get rid of this plus 4. Since they're adding a 4 to the x, then we're going to go ahead and do the opposite. We're going to take away 4 from the right side, remember, which means you have to take away 4 from the left side, just to keep it the same here. These are going to cancel out. 10 minus 4, that's 6. Keep the inequality the same. Bring down the x. Remember, these cancel, they zero out, so that's why I say that. And that's it for this answer. You can box it if you like. Now let's go to this one. We have x plus 4 is less than 12. So we need to get rid of that 4, similar to the other one. So we're going to go ahead and take away 4 from the left side, 4 from the right side. If you want to do the lines, you can, just so you can know that there's 2 sides. These are going to cancel, 0 out. It's x less than 12 minus 4, that's 8. And that's it. X is by itself, so you're done solving. So it looks like we got two answers, okay? Now, because your original problem, your compound inequality was like this, the variable was between two numbers, you can combine this as well. You can put the variable between the two numbers. And the way you do this, guys, the smaller number from the two will always go first. So the 6 is the smallest number, and then the 6 was less than the x, and then the x was less than the 8. Now this is your final answer. You have the variable between the two numbers. Now that you have it like this, you're going to go ahead and find those numbers on the number line and circle them. We have a 6 and we have an 8. So let's circle the 6 and the 8. And again, we have to determine if it can be open circle or closed circle. Since they're not equal in the bottom here, there's no equal sign on either one of them, then they're both going to be open. And then all you have to do is shade in the area between. So you can just shade it however you like, and there you go. That's how you do a problem like this. Alright guys, so now we're dealing with example number 3, and you might see inequalities that are separated like this with a word. So in this example we have the word and. It's pretty much similar to the previous example where the variables between the two inequalities. You're still dealing with compound inequalities. You have two inequalities here and you just have to just solve them, okay? So let's look at the first one, negative 3x greater than 6. You have to isolate the variable. So it looks like it's a negative 3 times x. The most common mistake that I see here when you're trying to get rid of the 3 here is that people want to add the 3 only because there's a negative in the front. But don't make the mistake. This is negative 3 times x, okay? There's an imaginary dot right there, right in between them. If you want to put the dot, you can put the dot. Negative 3 times x. So the opposite of multiplying is to divide. I would have to divide this by that same number so that I can get rid of that number. But what you do on the left side, you have to do on the right side, okay? Again, if you want to draw the lines, you can draw the lines. It was a negative 3 here, so I have to divide by negative 3 over here. These 3's, negative 3 divided by negative 3 is going to give you a positive 1. It's just a 1x, or an x by itself, or you want to say cancel, you can cancel. 6 divided by negative 3, you guys know what that gives you? That's going to give you a negative 2. When you're solving inequalities, guys, when you divide or when you multiply by a negative number, the inequality will always flip, okay? So it was greater than, now it becomes less than. Again, whenever you multiply or divide by a negative, the inequality will flip. Okay, so notice here, I divided by negative 3, so I divided by negative 3, the inequality flips. This is one of the answers. Now let's go ahead and do the other one over here. I have x divided by 7 greater than negative 1. So I need to get rid of this 7, and it looks like they're dividing the x by 7. So if they're dividing by 7, we need to do the opposite. That's to multiply by 7. So you can just go ahead and put parentheses or put a dot. I'm going to multiply this by 7. So over here, I need to multiply this by 7. Notice, we are multiplying by a positive 7. These are going to cancel. And so now we're left with the x greater than a negative 7. The inequality stays the same because here I did not multiply or divide by a negative. I'm getting rid of this 7 here by multiplying it with a 7. Okay? Since they're dividing by 7, I'm multiplying by 7, those cancel. So over here, I do the same thing. In this example, I divided by a negative 3. Okay? This side was a negative, so I had to cancel it out with a negative, which caused this side to be canceled out by negative, or divide by negative, and the answer changed signs. Some students like to say, oh, because it changes signs. Yes, you can say that. The 6 was positive, and now it became a negative. You flip the sign. The inequality here too. This 1 was a negative 1. I multiplied it by 7, it still stayed as a negative. So the inequality stays the same. Okay, however you guys like to see it. Now, like I mentioned before, this is the word and. Okay, when it's and, you can combine these two answers and put them the same. So you can put the variable in between the two numbers. Okay, and of course, the smaller number goes on the left, the bigger number goes on the right. So between the two negative numbers, the bigger the number, the smaller the value. So that's going to be a negative 7, and then the 2 goes over here. And of course, you can check it. X is less than negative 2, right here. X is less than negative 2. X is greater than negative 7. X is greater than negative 7, yes. So this is your final answer. Now that you have your final answer, all you have to do is find these two numbers on the number line, circle them, and then determine, are they going to stay open circles or are they going to be closed circles? Again, these inequalities don't have the equal sign, so you don't have to worry about coloring them in. Okay, so it stays open, and all you gotta do is shade in the space between them. And that's it, guys. That's your answer. All right, guys, so this is our last example, example number 4. It looks like we have another compound inequality. Two inequalities separated by the word or. So now you're dealing with the word or. It means either this or that, okay? So you have two separate answers. You're not going to be able to combine it like the word and. So let's go ahead and work this out again like we normally do. We have negative 9 times n greater than 27. So to get rid of this negative 9, again, divided by a negative 9, okay? It's not being subtracted, so you have to divide it. It's multiplying. So you divide the other side by negative 9. These 9s cancel, or negative 9 divided by negative 9 is positive 1, which is a n. Now remember here, you're dividing by a negative number, so when you divide by negative, the inequality will flip, and 27 divided by negative 9 will give you negative 3. So that's one answer. Over here we have n plus 6 is greater than or equal to positive 6, so to get rid of the 6, we just subtract 6 from the left and from the right. So these 6's equal to 0. Now I have n greater than or equal to 0. That's it. Our final answer is going to be like this. N is less than negative 3, or n is greater than or equal to 0. Now all you have to do is just graph it on the number line. So we have n is less than negative 3, well 3 and 0. You gotta circle these numbers and identify to see if you're gonna end up shading one of those circles, or any of those circles are gonna be closed. This one doesn't have an equal sign, so it's gonna stay open, but this one has an equal sign, therefore it's gonna go closed. That's the one with the 0. Okay, so let's go ahead and pick this one first. N is less than negative 3. I've mentioned in my class several times that on the number line, every time you move to the left, the numbers get smaller. So if n is less than negative 3, that means you have to go in this direction, to the left. Okay, here we have n is greater than or equal to 0. So n is greater than or equal to 0. Greater numbers always go to the right. You're getting bigger the further right you go. So over here you can just draw your arrow like this. Again, pick any number you like, a 1 or 2 or 3. Plug it in for the n, see what it gives you here. 2 is greater than 0, that makes sense. If I was to plug in a negative 2, negative 2 greater than 0, it does not make sense. Okay, so you know it's not to the left, it has to be to the right. And that's it, guys. This is how you map it on the number line. Thank you guys for watching. If you have any questions, let me know.